Hey, good afternoon, folks, and welcome back again to Wilderness Wargaming. Today, we're going to teach you how to estimate the probability of getting damage through to an enemy unit in 3 easy steps in just your head, even if you are not comfortable with doing arithmetic in your head here on Wilderness Wargaming. Alright, so a lot of people aren't real comfortable with doing math in their head, and especially when it comes to fractions. We remember when we were in elementary school and our teacher was trying to get us to multiply or divide fractions, and we're like, wait a minute, why does multiplying the fraction make it smaller and dividing make it bigger? This doesn't seem right, and we're all confused and we don't want to do it anymore. Or even if we're pretty comfortable with that math, it's hard to do it without a pencil and paper or a calculator. So I'm going to demonstrate to you here a technique for how you can pretty easily figure out a general estimate, not precise, but a good idea of what kind of damage you can inflict on an enemy in your head without really having to worry about fractions more than a minimal amount. Now, out there on the internet, you'll see videos or websites where they analyze mathematics and damage estimates and things like that in great detail and account for every conceivable modifier and reroll and things like that. And that's fine. That's great for analysis purposes and planning out your list. But when you're standing there at the table and you're trying to figure this out while your enemy is finishing up his turn, you need something that isn't going to involve you screwing around with your calculator for 5 minutes or trying to create graphs. And really, you don't care too much about decimal values of wounds because we only inflict full wounds in the game. So that's what this method is for. How you can do this very quickly when you're actually standing there during the game. Okay, now, if you are very good at math, you're going to find errors in this. That's fine. Remember, this is a method to get a rough estimation in your head. It's not intended to be precise or to be used for complex analysis versus point costs or anything like this. This is so an average person who likes to throw dice around and move plastic soldiers around, but isn't always great with math in their head, can easily do it quickly on the tabletop. I've included some explanation as to why it works. But remember that works here is very, very loose. It's just intended to get you a ballpark figure of, is this a waste of time or can I kill this thing? So, what you can expect from this. This will easily estimate your basic hit, wound, save, and damage probabilities. Okay, it will help you account for exploding 6 values, auto hits, and when you auto wound on all hits. It won't help you too much with hit rolls of 6 that auto wound. That's a little trickier. It will account for things like transhuman and poison effects and for invulnerable saves without making it any harder. It will also not directly account for, but it will make it pretty obvious what the outcome of having a feel no pain or wound shrug or damage reduction, whether it's by 1 per attack or half per attack, is. If you're dealing with something like one of those no more than 3 wounds per phase, well, that's easy. Your max damage is 3. We're not going to worry about that too much. What it does not do is account for reroll value. Rerolls are just too hard to really do in your head, other than very, very simple ones, such as succeeding on a 4-up. Well, if you get full rerolls, then you're going to succeed on a 4-up on the rerolls. So that's obviously 75%. But most of the time, it's too much math to do in your head very quickly at the tabletop. Okay, so the first step is we're going to try to combine the hit value and the wound value into a single die approximation. Okay, so we're going to start off by figuring out how many die faces can you hit on. Okay, so if you are, for example, attacking on a 3+, okay, you're going to hit on 4 faces. Obviously, you're going to hit 3, 4, 5, and a 6. Now, it doesn't matter why you hit on 3, 4, 5, 6. Let's suppose that your skill was actually 4+, but you had for some reason a +1 to hit. You're just going to add that in there for how many faces you will actually hit on as a practical matter. So in our example, we'll say 3, 4, 5, or 6. Same for wounds. So in our example, we'll take the brand new Brutalis Dreadnought attacking a Votan land fortress. So he's going to use his 2 multi-meltas to shoot at it, and our goal is to figure out how much it'll have left after we shoot at it that the Dreadnought will have to deal in the charge phase. Now, multi-meltas are strength 8, the land fortress is toughness 8. Now, although my picture is Ultramarines, because Games Workshop puts Ultramarines on everything, my chapter is Salamanders. So we get a +1 to wound with Meltas when we're in Tactical Doctrine. And we are in tactical doctrine, so that'll be 4 faces also. 3, 4, 5, and 6. Okay, you're going to multiply these two numbers together. Okay, so hitting on 4 faces and wounding on 4 die faces means you get a 16. Now, if you automatically hit, so for example, if you were using a flame weapon, just use a 6 for the value for what you hit on. If for some reason you automatically wound on all hits, multiply the hit value by 6. Now, once you have that value, in this case it's 16, we're going to round off to the closest of these possible values. 6, 12, 18, 24, 30, or 36. Now these numbers should look pretty familiar to you because these are multiples of 6 up to 36, and 36 is 6 times 6, which is what you get if you roll boxcars, 2 6-sided dice. That's as high as you can possibly get. Okay. The only thing you need to do with this here is round off to one of those actual die values, because we don't have partial die values when we're actually playing the game. And then remember if you rounded up or down. If you're exactly between them, just pick one or the other. Doesn't matter. And just remember whether you went up or down. Are exactly on top of one, then fine, you don't have to round. Each of these values relates to a die value, which is basically that number divided by 6. So remember from elementary school, 30 divided by 6 is 5. Okay, the reason this works is that each hit and wound is 2 dice rolls. So that means there are a total of 36 possible die face combinations rolling. Okay, just like if you were rolling 2 6-sided dice to make a charge or playing Monopoly. We're trying to figure out how many of these combinations of faces will succeed at both hitting and wounding. It works the same way as a charge, it's just working for a different reason. You're still dealing with 36 possible die combinations. We're rounding off these to a single die value in order to keep the next step easy in a reasonable approximation. Remember, we're trying to get an approximation here. We're not trying to get a precise value. Okay, next up, we're going to reverse the save. Now, what this refers to is the fact that what we care about is what results the enemy fails their save on. Since they're rolling the die, we care about failures rather than successes. We want us to succeed and them to failure. So, multi-melta has an AP of -4. On a 6-up, that's 5 failures. Now, yes, I get that the Land Fortress has -1 to AP because of Votan, and I forgot to include that in the slide. So we're just going to pretend that there's also some effect that gives us +1 to AP here to make it 6-up. So you're going to multiply this by the number one we got in step 1. Okay, we rounded up to 18, which is a 3 in terms of the die faces, and we're going to multiply that by 5. That gives us a 15. Okay, now we're going to round off again. But this time we're also going to, if you can remember to add these in, if this is too much to remember, don't worry about it, don't bother with it. We're going to include 9 and 27. Okay, now if you rounded up in step 1, round down this time. If you rounded down in step 1, round up this time. This is not going to completely correct any error, but it will help reduce it. Now if you didn't have to round, or if it was a tie, just pick one or the other. If you round up, you're going to get a slight overestimate. If you round down, you get a slight underestimate. The reason this works is, again, we're trying to eliminate worrying about the denominator, okay? The denominator is always a 36, so all we have to worry about is the numerator. Now, once you're done with this step, though, you may or may not have to deal with dice in the steps coming up. So we need to keep this to an easy-to-manage fraction, and that's why we round once again. The reason we include 9 and 27 is that 9 and 27 add in the fractions 1/4 and 3/4. Because 36, the result of 2 6-sided dice, is a number that's very easy to divide up, we get a lot of fractions to work with, and we can get a little more accuracy this way. So if you have a 6, that's 1/6, a 9 is 1/4, a 12 is 1/3, and so forth. But again, if you can't remember in this step to include the 9 and the 27 because you're just not great with arithmetic, don't worry about it. You can still round off to 6, 12, 18, 24, 30, or 36, just as if you did in step 1. Once you've rounded off, you're going to take that second value there, okay? Because it's just a total, it's just the fraction of attacks that are going to get through. This is what fraction of your total attacks are going to make it all the way through the hit roll, the wound roll, and the save roll. Now, we're going to compute the actual damage inflicted. So, remember that fraction that we obtained at the end of step 2, that 1/6, 1/4, 1/3, whatever. Okay. The numerator is the top number in the fraction, in case you forgot. For example, in ours, 1/3, because we were going to round down to 12 since we rounded up to 18 in the first step. Okay, so the numerator of 1/3 is 1. Okay, and then we're going to multiply by the total number of attacks. Now, the Brutalis Dreadnought is armed with 2 multi-meltas. Each one fires 2 shots. That's going to give us 4 total attacks. So 1 times 4 is 4. Now, if you have an exploding 6 to hit, add 1 for every multiple of 6 in your attacks value. So, for example, if the Brutalis had 6 attacks and had exploding 6s, we would add 1 more to that value because we could reliably expect an extra hit when we're rolling 6 dice. Not certainly, just reliably. It would be a pretty consistent result. If you want to, you can probably even do this if it's a multiple of 5, but if you start doing that across many multiples of 5, if you have a lot of attacks, you're going to be engaging in a considerable overestimate. So I recommend doing it only for every even value of 6 in your attacks value. Okay, now we're going to determine how many of the denominator will fit in completely. So our denominator was 3. Remember that when we rounded down to 12, we got a value that equals to a fraction of 1/3. The reason for that was 12 is 1/3 of 36, or the total number of possible die results from 2 dice. Okay, so our denominator was 3, and our result from part A of step 3 was 4. 3 fits into 4 once. Okay, so we can expect that we will reliably get one of those 4 attacks all the way through the hit gate, the wound gate, and the save gate and inflict damage. Now, our extra 1/3 that's left over just means that we have a reasonable chance of getting a second attack through, but it's not reliable. Now, remember, reliable does not mean certain. This is a dice game. It's possible you could miss all your attacks, or it's possible you could fail to wound on all the attacks that get through, but there's a very low chance of that. By the same token, our chance is not high of getting a second attack through, but it's not low either. That's where the 1/3 comes from. Our chances of getting a third or fourth attack all the way through all those gates are very low. Okay, now we're going to multiply that whole number we got. We're not going to worry about the fraction, just the whole number. That one attack we can reliably get through times 1d6 equals 1d6 of damage. Now, a single d6 is very swingy. Okay, the average value of one 6-sided die is 3.5, halfway between 3 and 4. But there are no half wounds in the game, and with no other dice, it's flat. Your chance of getting a 1 is just as good as your chance of getting a 6. We don't have any bell curve. That's why we express it that way. If you're rolling a 1d3, your average is 2. If you have a flat value, of course, you're just going to add up. You're just going to multiply the number of attacks that got through by the damage value. If you're adding up d3s, you can just multiply by 2. But with 1d6, it gets swingy. For 2 dice, you can probably multiply by 7, which is 3.5 plus 3.5. If you only have 1 die, you should, yes, technically your average damage is 3.5, but you have just as good a chance of getting 1 through as 6 through. So the real question is, how conservative do you want to be? Either way, you're going to have to use some judgment at this point. You're going to have to make a decision. Do I need to allocate another weapon? Maybe you have an attack bike nearby which has another multi-melta, and you can take 2 more shots, and that will get you a little bit more reliable damage. Maybe you're in melta range. If you were in melta range, then your minimum damage would be 3 and your maximum would be 8, which is a little bit better. You're going to have to use some judgment about whether or not to allocate any more fire to this thing or not. the land fortress has 16 wounds, so then whatever's left after that is what your brutalis is going to have to deal with in melee. Either way, there's no exact answer, but this is going to give you a good idea of what you can do uh, in terms of damage while you are physically standing there during the game in your head. You can also use this to compute the enemy damage coming in at you, but if you do this, make sure that you do not accidentally do everything in reverse. Final thoughts. This method is pretty good. Especially, I think this will work well for anybody who's playing in a tournament or in a game where you need to get through quickly because somebody has to go home or something. This will avoid having the complications of having to whip out a pencil and paper and trying to figure out that way, or trying to screw around with a calculator and forgetting to put in a parentheses or something like that in the right place. And it also eliminates the confusion of charts on some places that indicate probabilities of certain number of wounds or averages that include large decimal values and aren't really what you see on the tabletop. I hope that this is helpful for you and that you can easily employ this when you're playing the game. Thanks for watching here at Wilderness Wargaming, and once again, please remember to like, subscribe, comment, and hit the notifications bell so you can get more great content, and we hope to see you back again very soon.